Good morning, everyone. We will be going to report the scoring, language test, and assessment. The primary objective of this project is to promote scoring, language test, and assessment that is used students to achieve learning outcomes. It answers the following question. What are the strategies used in scoring language test? What is the importance of scoring language test and assessment? And how can these approaches benefit both teachers and students? Now, let's go to the introduction of scoring language test and assessment. Model and framework. The model and framework describes the what of language testing, the construct to which we wish to make inferences, and the domain in which we want to make prediction. Task. The tasks tell us about the how of language testing and the methods by which we elicit the evidence that we need. How can we score is the link between the evidence we elicit from the task in the one hand and the construct and the domain on the other. Scoring. Scoring is concerned with how much or how good of language testing we do in making inferences about person's ability to deal with social situations. A model or framework is descriptive and horizontal, and the scoring model is vertical. The scoring and how we arrive at very important. Score test may be to give detailed, explicit feedback to learners where no numeric score is necessary. How we arrive at a score and the meaning we invest in the score are extremely important. When score achieve iconic status, their meaning tends to become fixed. Defining the quality of language. Early attempts to invest language test scores with meaning related to an ability to perform in a real-world domain were made within the U.S. military. Rubrics or descriptors draw on elements of model of communicative competence that have been selected for the domain-specific framework. One of the first attempts to measure language proficiency was produced by the Foreign Service Institute in 1958. The definition of each level are written intuitively and may not characterize actual level. So let's begin with the level 1, elementary proficiency. It is able to satisfy routine travel needs and minimum courtesy requirements. Level 2, limited working proficiency. Able to satisfy routine social demands and limited work requirements. Level 3, minimum professional proficiency. Able to speak the language with sufficient structural accuracy and vocabulary to participate effectively in most formal and informal conversation, some practical, social, and professional topics. Level 4, full professional proficiency. Able to use the language fluently and accurately on all levels normally pertinent to professional needs. And level 5, native or bilingual proficiency. Speaking proficiency equivalent to that of an educated native speaker.
Hello everyone, I will be going to discuss the developing scoring system. A speech sample is awarded to a single number, and the meaning of that number is intended to generalize to a large number of other possible speaking tasks. Holistic skills have typically been generated in prior rounds, that is, by a committee of experts that attempts to define the construct of interest and sit down to write definitions that can be placed into a predetermined number of levels. In this kind of evaluation, the argument that the score adequately summarizes the evidence depends upon the acceptance of a collective understanding of the meaning of the descriptors. Primary treat scoring also allocates a single score to a performance. The scoring procedure is designed for each individual task or class of tasks. List the components of a primary treat scoring guide as follows. A description of the task, a statement of the primary trait, construct to be measured. A rating scale with level descriptors. Samples of performance to illustrate each level. explanations of why each sample was graded and the way it was. As rating skills is required for each task or task type, the development process is much longer and more complex. There are multiple skills that have to be used by raters if they are to assess more than one task type, thus making the rating process more difficult. However, primary trait scoring benefits from the requirement that there have to be very careful and explicit statements linking evidence to claims. Note, however, that the score tells only about the ability of the student to perform on a specific task or a specific species of task rather than task in general. What we gain in the explicitness and a stronger validity claim has to be offset against a reduction in the generality of the meaning we may wish to invest the score. Analytic scoring, which requires the counting of something, example errors in order to arrive at a score. Let's proceed to intuition and data. Database approaches differ in that they use multiple language samples to extract the criteria necessary to arrive at summarize of qualities. This can be done through the direct analysis of language and samples spoken or written. Using techniques of discourse or conversational analysis to describe samples, sample may be judged poorer or better by sets of judges, who then say which features in the samples lead them to make these distinctions. The resulting skills are known as empirically derived, binary choice, and boundary definition skills. Empirically derived relating to experiment and observation than theory. Binary choice in decision making, a choice in which there are only alternative yes or no, do or don't do. Boundary definition skills, the scale option can be used to scale the size or change the shape of the boundary.
Scoring and classical test theory. Classical test theory is a body of related psychometric theory that predicts outcomes of psychological testing, such as the difficulty of items or the ability of test takers. It means it is a theory of testing based on the idea that a person observe or obtain score on a test is the sum of true score, error-free score, and an error score. Generally speaking, the aim of classical test theory is to understand and improve the reliability of psychological tests. When we are dealing with samples of speech or writing, we have to design methods of assessing their quality in a way that leads to summary of that quality as a number of letters. When we have other items, types on a test, like multiple choices, it is much or more common to score this as simply correct or incorrect. Each test taker responds to each item in the sequence. If a test taker selects the K, a score of 1 is awarded. If a test taker selects a distractor from options, a score of 0 is awarded. In order to arrive at the score, the number of correct answers is summed and reported or transformed in some way. Or, in order to defend this approach to scoring respondents to test items, language testers have relied on a number of statistics that help to shape the test score. Faculty or item facility. According to Henning 1987, it is generally assumed that items should not be too easy or too difficult for the population for whom the test has been designed. Items with facility values around 0.5 are therefore considered to be ideal. with an acceptable range from around 0.3 to 0.7. While this is referred to as item difficulty, we should note the proportion correct is actually dependent not only on the difficulty of the item itself but on the ability of the test takers who are used in calculating the value. Technically, this is known as the sample dependence of the statistic. In other way to put it is that with a different sample of test takers, the value could be different. It is for this reason that the sample upon which the statistic is calculated should be genuinely representative of the population of test takers for whom the test is designed. Unless this is the case, scoring meaning is
problems with scales. The Cantor statements themselves have been drawn from previously existing scales, although these have been altered in order to cover inadequate gaps in efficiency continuum. These are the structure of the Common European Framework of Reference. The A1 and 2 are the basic users, the B1 and 2 are the independent users, and the C1 and 2 are the proficient users. The A1 are the breakthrough or the beginner, can understand and use familiar everyday expressions and every basic phase aimed at satisfaction of need of the concrete type. They can also introduce themselves and others can ask and answer questions about personal details such as where he or she lives, people they know and things they have. While the A2 are the way stage or elementary that can understand sentences and frequently use expressions related to areas of most immediate relevance. Example are the very basic personal and family informations, shopping, local geography, and employment. The B1 are the threshold or intermediate. They can understand the main points of clear standard and input and familiar matters regularly encountered in work, schools, and leisures, and etc. They can also deal with most situations likely to arise while traveling in any area where the language is spoken. They can also produce simple connected text on topics that are familiar or of personal interest. The B2 are the vantage or the upper intermediate that can understand the main ideas of complex text on both concrete and abstract topics, including technical discussions and their fields of specializations. They can also interact with a degree of fluency that makes regular interactions with native speakers quite possible without strains for either party. Another is the C1 or the effective operational proficiency or advanced, which can understand a wide range of demanding longer clauses and recognize implicit meaning. They can also express ideas fluently and spontaneously without much of the searching of for expressions. And they can use language flexibly and effectively for social, academic, and professional purposes. And the last one are the C2, the mastery or proficiency, which can understand with ease virtually everything heard or read. They can also express themselves spontaneously, very fluently, and precisely, differentiating finer shades of meaning even in the most complex situations. There is a general problem with level definition using can-do statements of this kind. How many of the can-dos must be able to do before we are in a level? That is, how can a single level summarize our performance? These problems is compounded by the fact that levels tend to be either under or overdefined. If underdefined, they do not contain enough information for us to match samples to the level. And if overdefined, no single samples is defined by just one level. Given the numbers of levels, it is often the case that we end up with statements like on average and individual would fit it into level X rather than Y. But the levels are not discrete enough for making a more certain claim.
Reliability. Reliability refers to how dependably or consistently a test measures a characteristic. It refers to the extent to which a test measures without error. These are the reason why a student does not get exactly the same test for every time she or he take the test. First is test takers' temporary psychological and or physical state refers to test performance can be influenced by a person's psychological or physical state at the time of testing. For example, different levels of anxiety, fatigue, or motivation may affect the applicant's test result. Second is environmental factors. Differences in the testing environment such as room temperature, lighting, noise, or even the test administrator can influence an individual test performance. Third is test form. Many tests have more than one version or form. Items differs on each form, but each form is supposed to measure the same thing. Different forms of the test are known as parallel form or alternate forms. These forms are designed to have similar measurement characteristics, but they contain different items because the forms are not exactly the same. A test taker might do better on one form than on another. The last is multiple raters. It means that in certain tests, scoring is determined by a rater judgment of the test taker's performance or responses. Differences in training, experience, and frame of reference among raters can produce different test scores for the test taker. Next is interpretation of reliability information from test manuals and reviews. Reliability coefficient value 0.90 and up is excellent, 0.80 to 0.89 good, 0.70 to 0.79 adequate. Below 0.70 may have limited applicability. Types of reliability estimates. First is test-retest reliability. Indicates the repeatability of test scores with the passage of time. This estimate also reflects the stability of characteristic or construct being measured by the test. Some constructs are more stable than others. For example, an individual reading ability is more stable over a particular period of time than that individual anxiety level. Therefore, you would expect a higher test reliability coefficient on a reading test than you would on a test that measured anxiety. For constructs that are expected to vary over time, an acceptable test-retest reliability coefficient may be lower than is suggested in Table 1. Second is alternate or parallel form reliability. It indicates how consistent test scores are likely to be if a person takes two or more forms of a test. A high parallel form reliability coefficient indicates that the different forms of the test are very similar, which means that it makes virtually no difference which version of the test a person takes. On the other hand, a low parallel form reliability coefficient suggests that the different forms are probably not comparable. They may be measuring different things and therefore cannot be used interchangeable. So, next, iterator reliability indicates how consistent test scores are likely to be if the test is scored by two or more raters. On some tests, raters evaluate responses to questions and determine the scores. Differences in judgment among raters are likely to produce variations in test scores. A high iterator reliability coefficient indicates that the judgment process is stable and the resulting scores are reliable. Iterator reliability coefficients are typically lower than other types of reliability estimates. However, it is possible to obtain high levels of iterator reliabilities if raters are appropriately trained. Lastly is internal consistency reliability. It indicates the extent to which items on a test measure the same thing. A high internal consistency reliability coefficient for a test indicates that the items on the test are very similar to each other in content. It is important to note that the length of a test can affect internal consistency reliability. For example, a very lengthy test can spuriously inflate the reliability coefficient. So these are the factors that affects the internal reliability coefficient. So, number of items on the test, variation in item difficulty, dispersion of score, and level of item difficulty. So let's proceed to Coder-Richardson Formula 21. We will consider two measures of reliability that are easy to calculate by hand. So these are the formula of Formula 21. R is equal to K over K minus 1. Set of X times K minus X over Ks squared, where K equals to number of items on the test, x mean of the test score, and s squared the estimate of the variance of test score. Example: k is equal to 10, x is equal to 5.65, s squared is equal to 6.86. So r is equal to 10 over 10 minus 1, set of 5.65 times 10 minus 5.65 over 10 times 6.86. So the result is r equals 0.40. So the next formula is the formula 20 to 0. Coder-Richardson's formula 20. So this is r equals k over k minus 1, set of s squared minus sigma pq over s squared, where k is equal to number of items on the test, s squared is the estimate of the variance of test scores, and sigma pq is the sum of the variances of all items. The third one is the formula for standard error of measurements. SE is equal to SD square root of 1 minus R, where SE is standard error, SD is equal to standard deviation of scores, and R is reliability coefficient. So let's proceed to test validity. Test validity is the most important issue in selecting a test. Validity refers to what characteristic the test measures and how well the test measures that characteristic. So these are the example. This is the first one is poor validity but good in reliability. The target B is poor validity and poor reliability. Target C is good validity and good reliability. So, which is more important, reliability or validity? So, validity is more important. If you measuring the wrong thing, it doesn't matter how will you measure it. Reliability is more important. If the score depends heavily on chance, you are not measuring anything. So that's it. Thank you for listening.
So we were done discussing about defining the quality of language, developing scoring system, intuition and data, problem with skills, scoring in classical test theory, and reliability. So now let's go further. I will discuss to you about the score transformations. Score transformations is not always the case that we report raw scores from a test. Frequently, the scores are subjected to a transformation process so that they are interpretable in terms of the normal distribution. Raw scores can be transformed so that they are expressed as a standard deviations, thus giving information on the probability of getting any particular score. Now, these scores are the most common form of transformation. Example, we have two observed scores of 7 and 5 respectively. The mean scores on the test is 5.65. Now the deviation scores is x are there. The raw score is 7 and 5. The mean score is 5.65. So 7 minus 5.65 equals 1.35, the deviation score, and 5 minus 5.65 equals negative 0.65. Now, to transform this into z-score or standard deviation scores, we will use this formula. For our two scores, we now have 1.35 divided 2.62 equals 0.52. Negative 0.65 divided 2.62 equals negative 0.25. Z-scores have a mean of 0 and a standard deviation of 1, creating an interval scale that is very easy to interpret. However, it is not common to present such low scores or give test takers negative scores. These scores are therefore calculated, which have an arbitrary mean of 50 and a standard deviation of 10. In order to achieve this, each g-score is multiplied by the required standard deviation and the arbitrary mean added to the number. For our two scores, this would give us 0.52 times 10 plus 50 equals 52.2. Negative 0.25 times 10 plus 50 equals 47.5.
What is item response theory? Item response theory is a term that covers a range of models used to score tests. Item response theory is a way to analyze responses to tests or questionnaires with the goal of improving measurement, accuracy, and reliability. In psychometric, it is a paradigm for the design, analysis, and scoring of tests, questionnaires, and similar instruments measuring abilities, attitudes, or other variables. It is a theory of testing based on the relationship between individuals' performances on a test item and the test taker's levels of performance on an overall measure of the ability that was designed to measure. It is also known as the latent response theory, refers to a family of mathematical models that attempt to explain the relationship between latent traits and their manifestations, observed outcomes, responses, or performance. Latent trait, often referred to as an observed score, is indicative of a person's ability on an underlying construct. Why do we use RIT? The use of item response theory, test designers can create a scale. A scale is usually scaled from -4 to +4, upon which all items or tasks can be placed, and the value of the scale is the item difficulty. Test takers who take the items can be placed on the same scale, and their scores are interpreted as person ability. As such, there is a direct connection between ability and difficulty. As we observe, the first thing to notice is that each estimate of difficulty has its own standard error, something that is not possible in classical task theory. This additional information is also provided in the estimate of person ability. The problem in classical test theory is that the standard error of measurement is more accurate at the test mean, but scores diverge from the mean. We know that the measurement error increases. You will notice that as the score moves farther from the mean, which is 0, the standard error of measurement increases. IRT applies a probabilistic model to the actual data. If the model cannot account for the data, a person or item is flagged as misfitting. What this means is that an instance of person misfit can usually be attributed to anomalous test-taking behavior of some kind. Such anomalous behavior may include cheating. In our case, 2 persons had the maximum score of 10 and therefore could not be modeled, and 1 person got an item wrong that a person of his ability would have been expected to get correct. IRT is also sample-free. That is, the item difficulty estimates are not dependent upon the sample used to generate them. As long as the sample was drawn from the population of interest, the estimates should be independent of the sample used. This also means that it is not necessary for every test taker to take every item in a pool in order to ensure that the item statistics are meaningful. Because of these properties, IRT has become the scoring method of choice for computer-based and computer-adaptive tests, where new items are selected according to difficulty on the basis of the current estimate of test taker ability. Why do we endow a score? We endow a score with a special meaning for the purposes of decision making. But when we do this, we should be very aware of the fact that there is always error in measurement. And we need to realize the chances that a score just below or just above an established cut point may in fact be a point estimate of a true score that falls at the other side of the cut point. Setting cut scores must also be done with sensitivity and associated warnings about their interpretation. The following are the two of the most common approaches to setting cut scores. A test-centered method, the Angoff approach. As the name suggests, this approach was developed by Angoff and relies on the use of expert judges. The approach consists of 5 steps. Step 1. Form a group of judges who are experts in the content area of the test. Step 2. Ask the judges to review the test and estimate the score at which they would begin to say that students were competent. Step 3. Present the judges with each item on the test in sequence. Ask the judges to estimate the probability that a student who is minimally competent will answer the item correctly. Step 4. Add up the probability estimates for each judge on each item and divide by the number of the test items, thus providing a percentage cut score for each individual judge. Step 5. Establish the final cut by averaging the cut score of each individual judge. Advantages and disadvantages of Angoff approach. Advantage: it uses the average judgment of people who are seen as experts in the field to establish a cut score. A standard that defines a minimally competent master. Disadvantages: the method described here can be used only on dichotomously scored items that are either right or wrong. Note also that test-centered approaches do not use student performance data. Method number 2, a student-centered method. Zicke and Livingston's contrasting group approach. While our first example required judgments about the test, the second concentrates on making judgments about students, and it contains 6 steps. Step 1. Identify a group of students drawn from the population of interest and a group of professional experts who are familiar with the students to act as judges. Step 2. Ask the judges to define good, borderline, and inadequate performance on the test. These should be written down as explicitly as possible. Step 3. Ask each of the judges to decide if each student is in the good, the borderline, or the inadequate category. Step 4. Give the test to the students. Step 5. Look at the distributions of the students in the good and inadequate categories separately to see how greatly they differ, especially in the terms of means and standard deviations. Plotting the distribution of scores is useful. Step 6. Make a decision regarding the best cut score that separates out the two groups, defined as masters and non-masters. The final step is not quite as straightforward as it sounds. Let us consider a specific example represented in the figure. The left-hand curve represents the score distribution of the students defined as inadequate in step 3 of the Zicke and Livingston method. The right-hand curve is the score distribution of students defined as good, competent, or masters. Cut score B. This cut score is arrived at because it is the point at which the two distributions cross. It is the point that best separates the masters and the non-masters. But notice that the curve for the masters starts at point A, and the curve for the non-masters finishes at point C. There will be some non-masters who are classified as masters, false positives, and some masters who will be classified as non-masters, false negatives. CAT score A. This CAT score is the start of the distribution of the masters. If we use this as the CAT score, there will be no false negatives. All masters will be correctly classified as masters. The trade-off is that the number of false positive will significantly increase. CAT score C. This CAT score is at the end of the distribution of the non-masters. If we use this CAT score, there will be no false negatives, and all non-masters will be correctly classified as non-masters.
In conclusion, overall, scoring language test and assessment is therefore very important. How we decide to score and the values that we place upon particular scores need careful thought. We need to convince others that the scores can be used to make inferences about learners, to the knowledge, skills, or abilities being tested. And we need to ensure that the use of the scores for decision making is undertaken with a full awareness of the possibility that a mistake could be made. The former concern is one of validity and the latter one of